Okay, this is our Chapter 9 Geometry Test Review. I think of this chapter as our trig test because we're really studying the measures of angles and side lengths as they relate to a right triangle. First thing on the test that you really need to know comes from section 9.2, Pythagorean Theorem, which states that a squared plus b squared is equal to c squared, or leg squared plus leg squared equals hypotenuse squared. So don't worry about, well, what if we don't have any a's, b's, or c's. Just take the two legs of the triangle, square them, add them together, and they should equal the square of the hypotenuse. And always take the square root at the end of the last step. So what we have here, I've drawn you two right triangles, and what we must do first in both of these, we'll start with the one on the left. We'll go ahead and call it number 1, and we'll call this one number 2. We need to identify the hypotenuse to know which one we need to set for to set aside by itself. Well, this triangle, the hypotenuse is always straight across from the right angle. So x is our hypotenuse. So basically we should be able to say that 1 squared plus 2 squared equals x squared. Since 1 and 2 are our legs. Now 1 squared is 1 and 2 squared is 4, which equals x squared. So we've squared them, now we just combine them, 1 and 4, add those together, and we get 5 equals x squared. But don't forget this step that says always take the square root at the end, and that should be your last step. So it doesn't matter if you're looking for a hypotenuse or leg, you still will take the square root at the end. And we will take the square root of both sides. The square root of x squared is x, and the square root of 5 is 2.25. So that lets us know that our hypotenuse is 2.25, and if we wanted to do a quick self-check, we know that our hypotenuse always has to be our longest side, in which that case it is. Now on this one's a little different. They have actually now switched our triangle up on us, but if we still locate the hypotenuse in that situation, which is 9, then we can very easily set it up. So we'll just say x squared or leg squared plus 7 squared equals 9 squared. And that's the way that our formula should look at the start. Then we go in and we say x squared plus 7 squared is 49 equals 81. And if you'll remember all the perfect squares we went over from 1 through 17, that should help you out tremendously on this. Now, we just need to get x by itself. So we say x squared plus 49 minus 49 equals 81 minus 49. That cancels the 49s on these sides. They're gone, and leaves us with just an x squared. And over here we'll say 81 minus 49, which will give us approximately 32, looks like. So 32 is what we are left with. Now we want to, once again, last step, take the square root of both sides. And the square root of x squared is x, and the square root of 32. And I'll show you on the calculator really quick. On this, if you are using a graphing calculator such as I have, we'll find that our square root button is right above the squared sign. So where it says x squared, right above is the x squared. Look and see if I can get that a little, make it a little clearer for you. And there it is. So there's my square root sign right above that. So anytime it's above it, I know that I need to hit second, push in my square root sign, 32. You can close parentheses if you want, enter, and I get 5.65, or let's just round it to 5.7. It should look something like that. So we round it to 5.7, and that is what x equals to. And I'll zoom out for you, and it would check out because 5.7, 9 is my hypotenuse, 5.7 should be not as long as the hypotenuse. So that is the Pythagorean theorem, and you use that to find the lengths of the sides, and can only be used when you have a right angle, a right triangle. That's section 9.2. Now on to section 9.4. We're kind of skipping some. I'm hitting the highlights from this of what I think is really important to test you on. So if we're not going over it in class or on this video, you won't be tested on it. All right, we come to two special right triangles that are formed based on angle measures. So when we have a 45-45-90, and then when we have a 30-60-90, some unique relationships between the angles and the opposite sides occur. A 45-45 triangle, 90 triangle, is also what we call an isosceles right triangle. So that means that these two side lengths are equal because the angles opposite them are equal. Now the ratio that comes up on that is very simply, let's just call 45 opposite it x. So if it's x, then this has to be x because these two sides are equal. And then to find the hypotenuse, or the side opposite the 90, we just take this and multiply it times the square root of 2. So an example would be like here, number 1, we have a 45 and a 90, so obviously this other angle has to be 45. And the sides opposite are 3. So if I go back to my formula, then I know that opposite the 45, if this was 3 and that was 3, then all I do is multiply 3 times the square root of 2, and would give me x is equal to 3 on the square root of 2. Don't need to go into our calculator and actually calculate that out to a decimal. So that is the 45-45-90. Now, the 30-60-90 also has unique relationships. The side opposite the 30 is our shortest side. The side opposite the 60 is our middle side. And then the side opposite our 90-degree angle is our hypotenuse, which is our longest side. Well, the relationship that happens opposite the 30, we'll call it x. That's our starting point. This side is the key that you can work all the others off of. Now to find the one in the middle, you just take the short side, which is x, and we multiply it times the square root of 3. And lastly, to find the hypotenuse, we take whatever the short side is and multiply it times 2. So you have x to x on the square root of 3 to 2x, or 2 times the length. Now in example 2 here, I give you two variables to find. I give you the x and the y. Now the tricky part of this is opposite. I don't give you what's opposite the short leg, and so conversely this formula always works, meaning that I give you what is the middle. So opposite the middle is 5. So that we know that we took x and multiplied it times the square root of 3 to get 5. We know that's how we solved it. So we said x times the square root of 3 is equal to 5. We know that much, but we don't know what x is. So if we were going to solve it algebraically, we just divide both sides by the square root of 3. That cancels and leaves me with x is 5. X is equal to 5 divided by the square root of 3. But you know that that's a no-no in math, that we can't have a radical in the denominator. So we have to do what we call rationalize the denominator, which is where we really easily just take the denominator, whatever it is, and multiply it times itself. So this would be square root of 3 times the square root of 3. And whatever we do to the denominator, we have to do to the numerator. We don't want to leave him out. And anytime basically what we're doing here is square a square root, the radical signs cancel and you're left with just the radicand, which is 3. And then on top we have 5 on the square root of 3. So that lets me know now that x is equal to 5 on the square root of 3 over 3. And if 3 and 5 had something in common and I could cancel, I would, but they don't. Now I have my short side, which was the key. So to find my long side, all I do is multiply this times 2. So I'm just very easily going to say 5 times 2, which will give me 10. So y is equal to 10 on the square root of 3 over 3. So that was a little bit trickier because you have that square root of 3, but if you'll remember that the short side, to go from it to there, you multiply times the square root of 3. And to go from here to there, from here to there, you multiply times 2. Whether or not, based on what they give you. And lastly, on this test, which we've worked plenty of, are our trigonometric ratios. Now, on these, what you must remember is our sine, cosine, and tangent. Sine is equal to opposite leg divided by hypotenuse. Cosine is equal to adjacent leg divided by hypotenuse. And tangent is equal to opposite leg divided by adjacent leg. Or, as I like to remember, so, ka, toa. Okay? So that is the way that I remember what goes with what. Now, I've put here, don't forget a 3, 4, 5 right triangle. A lot of times if you're trying to find side lengths and you look at the triangle and the two legs are 3 and 4, then the hypotenuse has got to be 5. And that only happens in a right triangle. That's what we call the Pythagorean triple. So don't forget that. You may see something on the test, like, I don't know, it may say bonus, give an example of the Pythagorean triple, in which you would put 3, 4, 5. It's probably the most widely used right triangle in all of mathematics, to know that one. Alright, so, knowing that we've got these trig ratios and we've worked so much, we can do two things with that. We can either find a missing angle or a missing side length. Now, if we're finding just a missing side, it's pretty easy. What I like to do is come in here, and they've given me 59 degrees, so I know I've got to use this angle. So I circle it. Then I like to say, okay, opposite is x. They did not give me the hypotenuse. I'm not looking for the hypotenuse. But I always put so, ka, toa. Now they've given me the opposite, so x is my opposite. Not given, but I'm looking for x. And then they've given the adjacent, or the side by side. The adjacent you'll never go across the triangle to find. It'll be side by side. Alright, so the hypotenuse is out, so that knocks out sine, that knocks out cosine. So I'm left with tangent. So the way I set that up is I just simply say tangent of 59 degrees, put that over 1, is equal to opposite of that, which is x, over 45. Now, you'll recall that if x is in the numerator, all we're going to do is simply multiply. If x is in the denominator, think denominator, you have to divide. Denominator, divide. So in this one, we cross multiply. We get x is equal to the tangent of a 59 degree angle times 45 degrees. So all I have to do is take my calculator out. I don't know if you can see. The calculator has buttons that say sine, cosine, and tangent. If we're just looking for a side length, we're just going to hit one of those buttons. If we're looking for an angle length, we have to hit the second button so that it gives us the -1 of that, which will give us the angle. But we're not looking for that in this problem. So I'm going to clear it out. So it says tangent 59. So I'll just simply say tangent 59. I'm going to close my parentheses so that I can go ahead and put times 45, enter, and I get 74.9, so we'll say 75 degrees. So the, that's the side length, not degrees. It'll be actually 74.9 is equal to my x. I want to round it to the 10th spot if I'm looking for a side length. If I'm looking for an angle measure, I want to round it to the whole measure. So that lets me know that the side of that triangle right there, where it is x, is 74.9. All right, now here's that infamous 3, 4, 5 triangle again that I'm trying to etch into your brain for you to memorize. And if you are finding sine, cosine, and tangent, you'll only find them of the angles that are the two acute angles, not the right angle. You'll never find it of the right angle for various reasons. Two of them don't exist, and the sine of a right angle is always 9. So you won't find that. So that is how you just find a side length. Now lastly, we're going to find the angle measure. So simply, all we're going to do, I still circle that because I'm looking for this angle. They give me opposite and they give me adjacent. So I know then, okay, opposite and adjacent, that's obviously tangent. So I'm going to go tangent of x is equal to 15.7 over 59. Now this is really easy to do. You just simply get your calculator out. Say 15.7 divided by 59, and it gives me 0.2661. It's always good when using trigonometric ratios to take it out to the 10,000th spot or 4 places past the decimal. Now, remember I told you if we're looking for an angle, which we are here, we want to hit the second button. So we're going to come in and go second tangent of 0.2661, that's plenty far out, equals 14.9, or about 15 degrees for x. So x is 15 degrees, and that is my angle measure. So if you'll study sections 9.2, 9.4, and 9.5, review your sheets I've given you. Don't forget the 3, 4, 5 Pythagorean triple right triangle. You will do fine on this test. Good luck, and we are finished.